Hi everyone, welcome back to Coding Problem Solving series, and today we are going to discuss Leetcode question 242, which is very famous by the name valid anagram. Now let's quickly read the question. So the question says that we have been given two strings S and T, and we have to return true if T is an anagram of S and false otherwise. Now an anagram is a word which is found by rearranging the letters of a different word, typically using all the original letters exactly once. Now let's see example 1, where we have been given two strings S and T, and if you look closely, T consists of all the letters of the string S, but in a different order. Now what I mean to say is, if you see the frequency of each letter in the string S, that is A occurs 3 times, N occurs 1 time, M occurs 1 time, and G and R also occurs 1 time, which is exactly same as that of string T, where N occurs 1 time, A occurs 3 times, G occurs 1 time, and similarly R and M also occurs 1 time. So hence string S is an anagram of string T and vice versa, so we return true. Now looking at example 2, if you see closely, the string S has a letter T which is not present anywhere in the string T. Similarly, string T has a letter C which is not present anywhere in string S, and hence S is not an anagram of T or vice versa, and we return false as our output. Now let's understand the approach to solve this problem. Now in our first solution approach, we will simply sort all the characters in both the strings. Now since in Java a string is immutable, so we will convert both the strings into array of characters and then sort all the characters in those arrays. So the array S1 for string S after sorting looks something like this. Similarly, the array T1 for the string T after sorting looks something like this. Now in the second step, we will simply compare both the arrays. And if S1 array is matching with T1 array, then we return true or return false if S1 does not match with T1. Now please note that since we are using sorting in our approach, so this will cost us time complexity of order n log n, which is good but still not the optimum. So let's see how we can reduce this complexity of O n log n to of order n with the next approach. Now in our second approach, we will simply calculate the frequency of each character in both the strings and compare them with each other. For example, A occurs 3 times, N occurs 1 time, and so on in both the strings, and by comparing the key and value pairs of both these strings, we can find out if they are anagrams of each other, and depending on the comparison, we can return true or false. Now usually we will use a hash map data structure for such problems, but we will use a hack for this particular problem since our keys exist in the range A to Z. That is, no character in both of these strings can be outside this range of 26 characters. So instead of a hash map data structure, we will simply use an integer array of size 26 with all the elements initialized to 0. Now initializing all the elements of this array to 0, let's start traversing both the strings one by one. Now starting with the string S, for each character in this string, we will increment the corresponding location in our integer array. That is, if A occurs on the first place in English alphabet string, then we will increment the 0th location of this array by 1. Similarly, because n occurs in the 14th location in our English alphabet string, we will increment the 13th index location of this array by 1. Now repeating this activity for all the characters of S, we will get an integer array string something like this. Now similarly, for string t, we'll traverse each character of the string and decrement the corresponding index location in our integer array. That is, for the first character n, we will decrement the 13th index of this array by 1 to 0. Similarly, for a, we will decrement the 0th index from +3 to +2. Similarly, for g, we will decrement the 6th index location from +1 to 0 and so on. So after traversing the string t, we will observe that all the elements in the integer array have become 0. Now at last, we will compare all the elements of this array, and if they are all equal to 0, that means we have to return true, and S is an anagram of T and vice versa. But if any element of this integer array is not equal to 0, that means there is some mismatch in the characters and we have to return false. Now let's code this solution. So here is our solution method is anagram, which takes two arguments s and t of type string and returns a boolean value. Now let's start coding. So at first we will compare the length of both input strings s and t, and if there is any mismatch between the length of these strings, then we will directly return false from here without any need to compare further. Next, we will declare an integer array of size 26 that will help us to calculate the frequency of all the characters in both the strings. Now let's create a for loop for traversing string s. Now inside this for loop, we will increment the corresponding index location of the integer array for each character of string s. Similarly, let's create a for loop for traversing string t. Now inside this for loop, we will decrement the corresponding index location of integer array ARR for each character in string t. Now we have traversed both strings s and t, and let's now create a for loop for comparing each element of our final integer ARR. We will create a for each loop to separate out each element of the integer array and see if every element is equal to 0 or not. Now, if we find any element of the integer array not equal to 0, then we can directly return false from here and break the loop, since it shows mismatch of characters between both strings. Now, if we are able to traverse through this for loop successfully, that means that both the strings are anagrams of each other and we can return true as our output. Now let's try running it for first test case. Great. The first test case is passed, and let's now submit the solution. Great. So our solution is accepted, and let's now see the time and space complexity matrix for this solution. Now since we are using 3 for loops, the first 2 for traversing the characters in the input strings S and T, and the third for comparing each element of the integer array. So our time complexity comes out to be 3n, that is of the order n, where n is the number of characters in the input string S and T. Now this becomes a linear complexity solution. Now coming to the space complexity, although we are using an extra space in the form of an integer array, but since it is of a constant size 26 and independent of the number of characters in the input string, so the space complexity of this solution is constant and is of the order 1. So with this, we come to the end of this video. Please like and share this video and subscribe to the channel for more informational content. Thank you and see you next time.